Okay, this is our tutorial, 3-story reinforced concrete office building. So, okay, this is using ETABS and safe. So, this is in accordance with the NECP 2015 and ACI 318-14M. So, ang kailangan lang natin dito is gravity and lateral loadings. So, we'll derive that. Then earthquake analysis, code discussion, load combination, wind drift and seismic drift. Okay, up to footing design. Then this introduction and itong mga code discussion as mentioned, ito you can read this one. So this tutorial is more on using ETABS and safe na lang. So you have to read this one, mga code excerpt. Okay, so punta tayo sa gravity and lateral loadings. So nandito, meron tayong sa 35 design criteria. So this is the loadings. So gravity. Okay. So you have to put up your design criteria first. Column, anong concrete strength mo. So let's say 4,000 PSI, that is equivalent to 27.6. So 4,000 divide 145 lang. Okay. Beams 3,000 and footing 3,000. Then deform bar, let's say we have 12 mm diameter and smaller, we have 275 or that is grade 40. Then 16 mm and above or larger, that is grade 60. Okay, next, so that is the material strength. Next is area load or SDL, that is superimposed dead load. Okay. You have, let's say, you have kung ano man ang mga floor loads mo. Dead load pa lang ito ha, superimposed dead load. So you have tiles, let's say 5 kg per meter squared. Then you have concrete fill finish. Okay. Or you can use here 50 times 24. It will give you, I'm referring to 50 mm times 24 kilonewton per cubic meter. That is cast in place concrete. Bubuhusan mo yung topping. That will give you 1.2. But pagka ano lang, yung pang finish lang na walang gravel, it will give you 0.023 times 50 mm, it will give you 1.15. So mas maliit siya ng konti, mas magaan siya. Okay, meron kang mechanical duct allowance, yung nasa ceiling na nakakabit. Then suspended steel channel ceiling system 0.5. So maximum na yan. So around ano lang to 0.38 to 0.4. Let's say we have 0.5. Then kasi office ito, we have partition load. So 1 kPa. So kung residential ka, kahit wala ka nitong 1 kPa na to, okay, it will give you 2.9 kPa. Then we have area load at roof deck level. So meron kang buhos doon, let's say 60 mm, kasi tatapingan mo yon, and sloping basically 50 mm to 60 mm or something like that. Then you have 1.42. Then yung ceiling mo 0.5 and then yung waterproofing mo 0.1. So it will give you 2 kPa. So times mo lang ito ng 100, itong kPa na to, times 100, it will give you kilogram. Let's say you have 2 kPa, it will give you 200 kilogram per meter square. Yan, ma-imagine mo na yung quantity ng loading. Okay, so okay na tayo dito sa superimpose dead load. So punta tayo sa line load naman. So it will give you for perimeter CHB wall, let's say 150 mm thickness. So meron kang height na 3.6. Let's say meron ka sa perimeter ng 600 mm depth. So magkakaroon kang CHB na 3 meter height. Then meron ka dito from NECP, meron ka ditong CHB loads. Let's say 150 yung thickness mo. So it will give you 2.63 na kilonewton per m squared. So ang mangyayari dyan, ito 2.63 plus plaster both side will give you 3.11. So 3.11 times 3 meter height will give you 9.33 kilonewton per meter. So then when you have glass line load, yung glass naman ito, so let's say 1.5 kilonewton per meter. Then sa roof deck mo, you have 1.2 height of CHB. Then ang perimeter mo naman doon is ito. Okay. Use SDL 1.15 kPa. Okay. Now, puntahan natin yung sa wind load. So let's say you have a map from this table in ACP. So you will have 260 km per hour. Okay, and this is the exposure category C, importance factor, and this is the code procedure to use. This is adopted by the NECP. Okay, then let's say we'll go to earthquake load combo. So this is the sample site location. Then you have importance factor of 1. So ito, basahin nyo lang ito, nandun yan. Then structural system, special moment frame resisting system, then reduction of base shear, ductility factor 8.5, store range, ground floor to roof deck, eccentricity ratio, that's 5%. Okay, then you have soil type SD, seismic source type A. So we have here, pag sa mga real project, you have to rely on this soil investigation report from geotechnical engineer. Okay, then seismic zone factor equals 0.4. Then distance to source is 6.1. Then pag na-input mo to, it will give you these values, NA and NV, CA and CV. Okay, so nandito lang din yan sa, so it will depend on this distance. Then this value is here, NA and NB. Okay, kaya magdedependent din yung CACB mo. Okay, then we'll go to floor plan layout. So this is the floor plan layout. So ito yung may CHB sa perimeter, and meron kang glass dito sa part na to. So may garden ka sa gitna. Basically sa second floor is butas yan. Second, third up to roof deck, that is opening and glass. Okay. Then this is the ground floor plan. Let's say you have here grade 1, 2, 3, 4 and A, B, C, D. Okay, you have 5.5, 7.5, 6.5. 5.5. Then 4, 6, and 4. Okay. So, okay, then second and third floor. So, ito pa rin siya. Meron tayong stair dito. Then office itong part na to. Let's say that is office. Then sa roof deck mo, this is your roof deck. So, hindi na siya office, roof deck siya. Okay, let's say that is accessible. Okay, so this is our column layout. So every intersection of grid, we have a column. Then we have a section. Okay, balikan natin yung live load. Nasaan na tayo eh. So, bago natin balikan, we have a section of the building. So, you have here ground floor. Okay. So, second, third, roof deck. This is the stair. Okay, so if you have a system here, then this is the lamp masses of every floor. So you have mass there. Let's say mass 2, mass 3, and mass 4. Then the ground acceleration is here. Then our earthquake story range is from ground floor up to roof deck. So pag may acceleration ka, this mass will be converted to forces. Let's say F2 from Newton's second law of motion, simple as that. So that you have here F3 and you have here, let's say, F4. So F equals ma. So that is the basic formula. Okay, hindi na ako sisimplihan lang natin. Okay, that's why that is our story range from ground up to roof deck. So the next, we'll go back to live load. Ito yung live load natin. So, refer to table here in ECP. You have to buy in ECP. Office live load 2.4 and lobbies and ground floor corridor live is 4.8. Then the stair live load is 4.8. So, ito yan. So, we'll use this 2.4 live load. Okay. Then, go to initial beam sizing. Basically, this is our ATABS elevation. So, initial sizing from the code. Ito, basahin mo na lang to. Then, we will have for 7.5 meter long span, you have L over 21 continuous both end. So, it will give you 360. So, we will use this initial sizing. Okay. So, 300 by 500 and 250 by 400. Okay. Column initial, let's say 450 by 450 from foundation up to roof. Then you have slab thickness computation. So you have here okay, items na kasi ito eh. So basically this is, I am referring to this slab. So 6 meter by 5.5. So ano ba ang thickness niyan? Okay. from the code provision, so kailangan mo yan na malaman. Kasi pag hindi mo to na satisfy na code provision na to, magdi-deflect yan na slab mo. Okay? And you will have a major problem. Then, you have to, this is for beam size. Sorry, this is for beam. So, sa slab tayo, ito. Nasaan na yung code na yun? So, we have a slab. So, slab thickness tayo. Kunin ko lang yung slab dito. Taas. One-way slab. Ito yung one-way slab. Okay. This is the thickness of one-way slab. So, pag one-way slab ka, so you have this thickness. Ito. Yan yung thickness mo. Simply supported, one end continuous or both end continuous. Okay, kung meron kang ganito, let's say 4 by 8. So it will give you two-way slab. But if this is, let's say 3, it will give you one way. So long span over short span, pagka greater than equal to 2, it will give you one-way slab. Then, pagka long span over short span less than 2, it will give you, this is one way. Then, it will give you two-way. Okay, so, for this example, we have 8 and 3. So, 8 divide 3, that is greater than 2. So, punta dito ka sa one way. But in the case of our case, you have in the sample 5.5 all over 6. So, it will give you two-way. So, sa two-way slab naman, hindi ka pasok dito. So, hindi mo magagamit itong table na to pagka two-way ka. So, hindi yan. So, sa two-way, you can use perimeter over 180. Yan, perimeter over 180. So, basically, if you have 5.5 plus 6, so that is 11.5 times 2 mo, 23, divide mo ng 180, it will give you 127 mm. So, you can use 150. Okay, so balik tayo dito sa slab thickness. So, ito, meron ka ditong figure nandyan sa sa PDF na sinend ko. You have here derived thickness. Okay, so ito, kahit ito, you can check to see, but I should say na you can you have here your thickness, perimeter over 180. This is validated also by the code, yung mga previous codes. Ngayon kasi tinanggal ito sa code nagkaroon to ng mahabang formula, then the resulting will give you perimeter over 180 times 1.15 or 1.10. Yan yung variant based sa experience. Okay, then the 150 mm thickness is compliance to code. So we can remove this check safe na to. Basta ang importante, unang-una mong gagawin, kailangan tama yung thickness mo before you go to modeling man ng kung anong structure man. Kasi pag mali yung thickness mo, mali yan lahat. Kasi that is the the dead load or the mass of the building will play major role in structural analysis. Pag mali yung thickness mo, lahat yan mali na yan. Okay. Then, mamodel na natin to. So, there is a code provision and you can read all of this excerpt from the code. Okay, so we'll go to start of modeling. So this is video number 2. Okay, so we'll proceed to video number 2. Cut ko muna to dito.